I want to talk to you today a little bit about our new product, which is our interference detection system. Its whole purpose in life is actually to go out and identify and characterize interference sources for GPS and GNSS systems. The way it works is that it basically characterizes the interference signal source and can identify whether it's an intentional signal or actually an unintentional interference source, which might be noise from some sort of local oscillator. The whole purpose of the tool in our standard implementation is to develop a solution that we can offer to folks that can begin developing a database of interference profiles so that we can begin to build up a knowledge base and start to identify how bad interference issues are going forward in the future. And I'd like to show you a little bit about that in our product over here on our screen. This is our interference detection system product right now, showing a sweep jammer that is jamming the L1 frequency both at the CA and PY channels. And using our proprietary algorithms, we're able to detect these signals and actually very accurately measure their jamming ratio, as the image on the lower part of the screen. Part of the way Loctronix views the world is that to address interference issues accurately, the first things you need to do is A, identify that you're being interfered with, B, characterize that interference so you can establish what kind of interference it is. In this case, it's an actual active interference jamming source, or a sweep jammer. The third step in the process after that is a mitigation process, where you can then either A, try to reduce its effect upon your system, or as a fourth step, then go after geolocating it. The product that we're offering here today is the first part of that process, and it works through a software-defined radio package and can run on any Windows platform machine. So after you've done the interference detection and characterization, the next step in the process is to mitigate the interference source. One of the techniques that we use in our system is to apply a positioning method known as spectral compression positioning, which allows us to basically continue to process GPS signals even in the presence of strong interference. As this video is showing, the blue line indicates traditional GPS receiver dying in about a 15 dB J/S situation, where our advanced algorithms using SCP can pick up and continue to operate well into 20 dB J/S and even higher, all the way up to 30 dB J/S jamming situation. Once the interference has dropped down to a level that correlation technologies can deal with effectively, we can return back to an ordinary operating state. The technology behind all this today is implemented on a software-defined radio platform and is available for embedded applications, as well as developing for laboratory and research implementations. So here's the box, and it runs with a USB interface for implementing easy connections, USB 3.0 to the host PC, and has a bunch of standard SMA interfaces on the backside that you can connect to the various RF inputs or outputs that are available to you on the device itself. The ASR 2300 is a 2x2 multi-input, multi-output transceiver system with integrated accelerometer, inertial capabilities, and barometer. So it has the full complement that you might need to do advanced navigation, both in indoors as well as outdoor location, using either GNSS signals and signals of opportunity, which include things like digital television, could be jamming signals like we showed earlier, or cellular, or in certain cases we've actually hooked this up to a K-band satellite system and done geostationary satellite downlinks.